In this video, we're going to be looking at derivatives of logarithmic and exponential functions for the most part. And there's 8 problems altogether here. And we'll look at the main formulas that we're going to be using. And here u is a function of x, so I'm using u prime to mean the derivative of u with respect to x. So the first one's really a special case of the second one here. Here the base of the log function is a, and of course in the first one the base of the log function is e, and the natural log of e to base e is 1. That's why you don't see it here. And again, on the next two, we have the derivative of a to the u is ln of whatever the base is times a to the u times the derivative of u with respect to x. And on the next one, derivative of e to the u, of course you don't see the ln there because ln of e, which is the base, is 1. So let's look at these. So we have natural log of x squared. So in this case, the u is x squared. That goes in the bottom. And then on top, numerator is the derivative of x squared, which is 2x. And you can reduce it, divide through by a factor of x there, and you get 2 over x. And that's the answer to that one. Now the next one is the derivative. And I could do this a couple of ways here. I could say, okay, the radical right here is u, and that's going to be in the numerator. The derivative of that expression would go in the numerator, and then the radical expression would go in the denominator. You can simplify. But whenever possible, try to simplify this. I have a log function here, so I'm going to use the properties of logs. This radical can be written as x to the 4th minus 4x to the 1/2 power. So I have a property of logs that allows me to, and I haven't taken a derivative yet, so let's just make this as y. So here I'm just simplifying. So this is an x squared, or x to the 4th rather, minus 4x. Then now I take the derivative. So this would be y prime, and then I got a factor of 1/2, that's constant, so I can just leave it out here. And then I'm just looking at this, the derivative of that. The u here would be x to the 4th minus 4x, and then the derivative of that will go in the numerator, so that would be 4 x to the 3rd minus 4. So it's 1/2, and then in the parentheses I have 4x to the 3rd minus 4 over x to the 4th minus 4x. And then we can go ahead and simplify the 4 and the minus 4 are divisible by 2, so we divide that out. Factor of 2 there, so this will be 2 x to the 3rd minus 2. And that's over x to the 4th minus 4x. And that's your answer for that one. Now for number 3, again, before I take the derivative, I'm going to simplify this. I have the natural log of a rational expression. There's a property of logs that allows me to break that down into the difference of two logs. So it's a log of the numerator minus the log of the denominator. Now you can work this out without doing this. You could just treat this expression here as u, and the derivative of that would be in the numerator, and then the whole expression will be in the denominator, and then you simplify. But this works out easier. So now I'll take the derivative. So y prime would equal to, I have the derivative of ln of x. That's just the derivative of u. In this case, the x is the u. So derivative of x is 1, and that's over x. Then I have a minus the derivative of the log here. Take the derivative of this u here. That would be 2x over the x squared plus 1. Now that's the answer. Your instructor might want you to simplify this or combine it, so I would accept it this way. But let's go ahead and combine it. Lowest common denominator is x times x squared plus 1. So then multiplying this by x squared plus 1, we got an x squared. And we got a minus. This one multiplied by x, minus 2x squared. So I got everything over the same denominator. Simplify. X squared minus 2x is a minus x squared. That's plus 1. And that's over x times x squared plus 1. And that's the answer for this one. Number 4, pretty much similar problem. Okay, this is equal to, no derivative yet, I'm simplifying here. So I can think of this as the square root of x plus 1 in the numerator and the square root of x minus 1 in the denominator. So again, using the same property as just went over, this can be written as natural log of the square root of x plus 1. But I'm going to bring the fractional exponent out here. This will be x plus 1. And then it's going to be a minus ln of the square root of x minus 1. But again, the square root of x minus 1 is x minus 1 to the 1/2. So again, properties of logs allows you to bring the coefficient out here. This is x minus 1. Now we're ready to take the derivative. So the first expression here, I have the 1/2 here, and the derivative of that would be, the derivative of x plus 1 is 1, and then the x plus 1 goes in the denominator. Same thing with the next one. Got the minus 1/2. Derivative of x minus 1 in the numerator is 1, and then that u, in this case x minus 1, goes to the denominator. And like I said, that's basically your answer there. But you can again find the common denominator, and you should get minus 1 over x squared minus 1. Now some instructors might accept it this way. 1 over 2 and then x plus 1 in parentheses minus 1 over x minus 1 in parentheses times 2. Some might want you to combine it. So if you get your common denominator, you're going to get that. Now for number 5, same sort of thing, except now I have base 3 here for the log. But the same properties apply. If I have the log of a fractional expression, that'll be the log of the numerator minus the log of the denominator. So in this case, I can rewrite this as the log to base 3 of x times the square root of x minus 1 minus the log to base 3 of 2. And then we can further expand this using properties of logs. I'll have the log of a product, which is actually written in parentheses this way, just to clarify that. You have the log of a product. You can write it as the sum of the logs of those factors. So this would be the log of 3, which is a log to base 3 of x plus the log to base 3 of the square root of x minus 1. But again, the square root, I'm going to bring that fractional exponent up here in front. This will be x minus 1. Now we're ready to take the derivative here. So I'm going to just say y prime is equal to. So now I have the log of x to base 3. So it's kind of similar to the natural log pretty much. Derivative of x is 1. And the x goes in the denominator. And then the denominator is multiplied by the log of whatever the base is. And this is the ln of the base. LOG with no base is understood to be base 10. So it's ln of 3. So I'll put it in parentheses just to make clear that it's that product there. And then it's going to be plus 1/2. In the same way, it's the derivative of the u, in this case x minus 1 is 1 over x minus 1, that's your u. And again, this is multiplied by the natural log of the base of the log, which is 3. So that's 2 times the natural log. And of course, this is just a constant. The log of 2 to the base 3, that's 0. So again, this is your answer. But you doing a little bit of algebra, you have a factor here of 1 over ln of 3. So if you take that out, the instructor might want you to simplify this. So this will be 1 over ln of 3. And then you would have, in the parentheses, you would have 1 over x plus 1 over 2 times x minus 1. If you do that algebra, then this comes out to 3x minus 2 over 2x times x minus 1. So if you simplify it, this is your final answer. But some instructors, I know I would, especially on a test when you kind of rush to finish, I would accept it this way here. Okay, the next one we have the exponential 3 to the 6x squared. So this one we can just proceed with the derivative using the formula we just went over earlier at the beginning of the video. So the derivative of an exponential of this form is always going to have the exponential. So 3, and this will be 6x squared, and then it's going to be the derivative of that represents u. So I'll just put it over here, 12, then 12x, and this one has times the natural log. I'll go ahead and put it in front in parentheses. I'll put it over here. This is going to be the natural log of whatever the base of that exponential is, in this case 3. So that's your answer. 3 to a power of 6x squared times 12x times ln of 3. And the next one is pretty much just a product rule and using the formula for the derivative of the exponential e. So if we start off with the product rule, so it's the first function times the derivative of the second. So that's going to be derivative of e to the 2x is e to the 2x times the derivative of 2x, which is 2. I'll put that out in front. 2 e to the 2x. And then it's plus the second function, which is e to the 2x, times the derivative of the first. Derivative of x cubed is 3x squared. That's your answer for that one. And then for the last one we have exponential here, another exponential here, times a log, natural log of pi. So this will be the derivative of the first one. Derivative of 7 to a power of 3x squared is that power to the 3x squared times the derivative of u with the exponent there. So this will be a 6x, and then it's times the natural log of whatever the base is. In this case it's 7. So it's clear here, I put this in parentheses. So we have ln of 7 times 7 to the 3x squared times 6x. Then we have a plus. Now don't think if this is a product. Now had this been say ln of 3x or ln of pi x, then you can think of it as a product rule here. Doesn't have an x. Pi is just a number, it's a constant. So here we just take the derivative of e to the 2x. That's going to be 2 e to the 2x. Derivative of e to the 2x is e to the 2x times the derivative of the exponent, which is 2. And then the other part is just constant, so you just bring it along for the ride. Just put ln of pi. Thanks for watching. We'll see you next time.